Good morning, students. My name is Gustavo Berre. I'm an electrical and computer engineer. I've graduated in electrical and computer engineering from Addis Ababa University. I'm from Addis Ababa, Ethiopia. And I will know each of you in the next time. So for today, since we have no time, we're going directly to the lecture. As you remember, last time we have discussed about set, relation, function, and some things like that. So today we'll continue our lecture by discussing on this contents, function, type of functions, constant function, identity function, up to trigonometric function, and lastly at the end of the lecture we will discuss about the composition of functions, and also we'll see the effect of these functions in our daily life. Thank you. So function as a set of ordered pairs. Let A and B to be non-empty sets, and a relation f from A to B, which means a subset of A times B is called a function if it meets the following preconditions. The first one is for each A, an element of A, the small letter A, an element of capital A, there exists B, which is an element of B, capital B, such that A comma B will be an element of the function f. And the second one is if A comma B is an element of f, and also A comma C is an element of the function f, then it will imply that B is equals to C. The element B will equal to C. Function as a correspondence. Let's A and B be two non-empty sets. Then the function f from set A to set B is a rule or a method or a correspondence which associates elements of set A to elements of set B, such that all elements of set A are associated to elements in set B, and also a single element, a unique element of set A is associated with a single element in set B. Note that if A and B are two sets having m and n elements respectively, then the total number of functions from A to B is n to the power of m, which means n times n times n up to m times. For example, if the number of elements for set A is 2 and the number of elements for set B is 3, then 2 to the power of 3 is equals to 8. The number of functions will be formed from this elements of sets. Well, as we have discussed on the contents of the first PowerPoint, constant function is another type of functions. So if k is a fixed real number or a constant number, then the function f of x given by f of x is equals to k, that constant number. For all x is an element of real number is called constant function. As you can see from the simulation here, the graph, for h of x is equals to every single number, there will be a horizontal line that cuts the vertical y-axis from negative y-axis to positive y-axis. This type of function only crosses the y-axis and is perfectly parallel to the x-axis. Well, an identity function is associated with each real number to itself. It's called an identity function. It's usually denoted or represented by the capital I, and as you see from the figure, this line passes the real line, just like the real line. It passes through the origin of the graph, and it increases from negative infinity to positive infinity, and it's a straight line that passes through the origin 0, 0. Modulus function is a type of function which is defined as the absolute value of x. As we have discussed from the lower class, absolute value of x means it has two possible outputs, positive x or negative x. Positive x when x value is greater than or equal to 0, and negative x when x is less than 0. As you see from the figure, the function f of x or the module of x for positive value of x is just like this. It goes from 0, 0 to positive infinity, and the function of f of x for negative x value is just like this. It goes from the origin to the negative x-axis directions. Well, and the greatest integer function, as this is also called the float function, as you see from here. It is just a steeping function. As you see here, it has a graph like this. The other function is a synonym function. The function f is defined by f of x is equals to absolute value of x over x for x is not equal to 0. Remind that for x is not equal to 0, this function is defined as the absolute value of x over x, and 0 for what? X is equal to 0. Or in other representation, f of x is equal to 1 for x is greater than 0, 0 for x is equal to 0, and negative 1 for x greater than 0. As you see from here, if the x value is positive x, then x over x is equal to 1, which is 1 for x greater than 0, and for the value of the output of absolute value of x is equal to negative x over x is equal to negative 1 for x greater than 0, and 0 for x is equal to 0. As you see from the figure here, f of x is equal to 0 for x is equal to 0. As you see from here, the capital A, the red dotted A, and this function has positive 1 for all positive x values, as you see from here. So this expression could be defined like this within a picture, with a picture. So, and it has a negative 1 value, a constant negative 1 value for all negative x values. Well, the second function is exponential function, a function for f for r in real number defined by f of x equals to a to the power of x, where a is greater than 0 and a is not equal to 1. If a greater than 0 and a is not equal to 1, f of x is equals to a to the power of x is called an exponential function. A is called base and x is called exponent. Well, so for the value of a in between 0 and 1, what look like its figure, its graph? When you see it in pictorially, for f of x equals to a to the power of x, 0 less than a less than 1, which means a is in between 0 and 1, the function looks like this. For the value of a, which is approaching or nearest to the value 1, the graph will go away from the positive y-axis, as you see here. And if the value is near to or decreases towards 0, the function, the upper parabola, the upper half parabola will approach to the positive y-axis, as you see here. And what if the value of a is greater than 1? For the value of a greater than 1, the graph looks like this one. If the value of the a is approaching or goes far from 1 up to infinity, the graph, the upper parabola, the upper half parabola will approach to the positive y-axis, and if it decreases, it will go away from the positive y-axis, as you see here from the simulation. And the next function is logarithm function. Logarithm function and exponential function have very similar characteristics, and we can change logarithm function into exponential function and exponential function to logarithm function. We will see it in the future, but they have the same property. They're only different in their characteristics and nomination. If a greater than 0, just like the exponential function, they have the same properties. If a is greater than 0 and a is not equal to 1, then the function defined by this formula, this format, is called logarithmic function. F of x is equal to logarithm of x in base 0.67. A is base and x is just normal function. And the other thing, the other type of function that we're going to see is even and odd function. As you probably understand or remember from the lower class, even number and odd number. Even number is a number that could be divisible or could be divided by 2 without any remainder. Remember? Do you remember? Yeah, good. So even number is a number that could be divided by 2 without any remainder, and odd number is a number that couldn't be divided by 2 without remainder. So there will be a fraction if we divide that number, if we divide an odd number with 2. when we see it in function way, an even function is a function which has a property of negative x is equals to f of x. F of x is equals to x squared, for example. If you see, if we substitute number 2 instead of x, negative 2, the power of 2 is equals to negative 2 times negative 2, which means 4. And if we substitute 2 in the same function, 2 times 2 is equals to 4. 4 is equals to 4, which is the same. F of negative x is equal to f of x. But when we come to the old function, f of negative x is equals to negative of f of x. If we substitute negative 2, for example here, negative 2, the power of 3 is equals to negative 8 plus x is equals to plus negative 2. That means negative 8 minus 2 is equal to negative 10. If we add the positive 2 to the power of 3, 8 plus 2, 10. Negative 10 is not equal to 10. So they are different. We'll see in detail in the future. And there is a quality of function. I think it's enough for today. If you have any questions, you can ask me now. It's time. Well, I hope everything is clear for you. And if you have any questions, you can contact me anytime you want. During the class also, and also out of the class, you can ask me, you can write me any questions you have. Thank you for today. We'll see you in the next class. Have a great time.